This is lesson 4.5.1 on simplifying radicals. And this is period 6, December 5th. Alright, so first thing is we've got some definitions, alright? The definition of a square root is the inverse of raising a number to the power of 2. So we have that written in English here, and then we have this algebraic expression that is also considered to be the definition of a square root. So if we take a number, in this case I'm calling it r, and I raise it to the power of 2 and say, well, that equals s. Well, by definition, that means that the square root of s is r. Now, sometimes it's a lot easier to understand what all of that means when you put some numbers in there to help it make sense to you. And that's why I have the next line here. So this one says, if I take 3 and I raise it to the power of 2, that's 9. Well, by definition, that means that the square root of 9 is 3. Okay? Then I've got some vocabulary words. Okay? This symbol here is called a radical. And the radicand is whatever's underneath the radical. So if I gave you this problem right here, square root of x plus 5, and I ask you what is the radicand, you would answer x plus 5. Okay, so all of that is just vocabulary and definitions. Here's 3 problems for you. Please write that down. So I'm using the definition of the square root to simplify these expressions. So when I ask you what's the square root of 25, that means, well, what number do I multiply by itself that gives me 25? Yes. So the square root of 25 is 5. What's the square root of 81?
9.
What's the square root of 169?
Pretty sure that's 13.
Good.
Where
Very nice.
does this energy come from? What are you
Got
taking
all
it
that?
from? What are you taking it from? I want some of that. What are you taking it from?
Write down the rule that's up top, please. Square root of a times b equals the square root of a times the square root of b.
I'm not trying to kill you, Bob. I'm not trying to be that toxic person.
And then I'm going to do these problems with you. Alright, so maybe you know what the square root of 400 is, maybe you don't. Okay? But if you don't know what the square root of a number is, you can use this rule to kind of help you calculate it in your head without getting out a calculator. So I know that 400 is equal to 4 times 100. You with me? So that means that the square root of 400 is equal to the square root of 4 times the square root of 100.
Which is 2 and 10.
Which is 2 times 10, which is 20. Okay, so that's one way you can use this rule. So you can actually do that in your head pretty quickly without even writing anything down.
That's fine.
Okay, but I wanted to write it down. Why? Because we're going into harder problems. So we saw one that's a perfect square. We use that method. Now we're going to see one that's not a perfect square. Okay, and what do I do with that one?
106 and 4.
Very nice. So what I'm going to do with the square root of 24 is I'm going to ask you what perfect square divides 24 evenly.
It's really 12. No, that's not true. Pretty sure that's 6. No, that's 6.
2 is not a perfect square. Go ahead.
4 and 6.
4 is a perfect square. And 4 divides 24. Okay? So 6 is only divisible by 2 times 3. So I'm not going to be able to break down 6 into any perfect square. But what I can do right now is I can rewrite square root of 24 as square root of 4 times the square root of 6. What's the square root of 4? So 2 radical 6 is considered simplified form. That's the most simple you can make that radical.
That's pretty good, huh?
Good?
Pretty gnarly.
No, wait.
No, wait, I'm sorry. Go back.
No, you're good, I'm sorry.
We're good?
Did you need that?
Do 6 and 7 for me, please. I think you can do these by yourselves. Or do you want me to do one more example before I let you do these by yourselves? No, you can do this.
Tricky because you said even square, right? And that's 11 and 4.
Right, but it's for a perfect square?
Yes.
Oh.
Well, then you're good.
But 11 isn't.
So you leave 11 under the radical.
Oh.
All right, I'm going to do this, and then I'll let you try 7 because a lot of people are still like, what? So 44, I'm looking for a perfect square that's a factor of 44. It's 4. 11 is prime. It has no factors that are perfect squares. So I'm just going to rewrite this as square root of 4 times square root of 11. Square root of 4 is 2. I leave 11 under the radical. That part cannot be simplified. So go ahead and try to simplify square root of 60. All right, so what factor of 60 is a perfect square? 4, wonderful. 4 times 15 makes 60. 60 is only factorable by 5 and 3. Neither of those are perfect squares. I'm going to rewrite square root of 60 as square root of 4 times square root of 15. Square root of 4 is
2.
bring down square root of 15. That's considered.
Oh, I got it.
Oh, I
Easy.
got it.
Good.
I feel proud.
It's not that hard.
Y'all little fool.
Every year I've got students that have this huge mental block, but it's not that hard. 8, I'm going to do this one with you. Square root of 80. I need a factor of 80 that's a perfect square.
Oh, 40 and 2.
You're so.
No, oh wait. Wait,
Neither 40 nor 2 are
No,
perfect
I was.
squares.
It was
a
kidding.
joke, I know.
Yeah, it was
What? 4. So 4 is a perfect square and it divides 80. Okay? Now, take a look at 20. Can you tell me a perfect square that divides 20?
No.
Oh,
4, good.
What?
4 is a perfect square and it divides 20.
Oh yeah.
Okay? So 5 is prime. It has no factors that are perfect squares. I'm done my factor tree. Okay? So I'm going to now substitute in here square root of 4 times square root of 4 times square root of 5. What's the square root of 4?
2.
So I have 2 times 2 times the square root of 5, right?
Oh my gosh.
2 times 2 is?
4.
There you go. That's the simplest form.
oh.
4 square root of 5.
Got it.
Now, I want to do that problem again.
It's not even that funny.
Again. I'm going to do it right here. Why? Because I want to show you that these can be, they're not only just one way to do a problem.
Yeah.
Okay? So you see my factor tree here. Here's my factor tree. You looking at this?
Yes.
What's 4 times 4? 4 times 4 is 16. So what I could have done is I could have written my factor tree as 16 times 5 if I wanted to. 16 times 5 makes 80.
Yeah.
Okay? Is 16 a perfect square?
Yeah, it's 4 times 4.
It is. As a matter of fact, any 2 perfect squares that you multiply together always makes a bigger perfect square.
You're right.
Okay? So, so if I get a bigger perfect square, I can do this in just 2 steps instead of 3. I can do it quicker. So I can rewrite this as the square root of 16 times the square root of 5, which is 4 radical 5. So it's the same answer, but if you get a bigger perfect square that's a factor, you can do it quicker. Okay?
Yeah, man.
So if you know the biggest perfect square, wonderful. If you don't know the biggest perfect square, you can whittle it away by taking smaller perfect squares. I want you to try all 3 of these, please. No, I don't. Never mind. I'm going to do square root of 18 for you. Or we'll do it together. What's the square root of 18?
Gonna be 6 and 3, 2 and 9.
9 and 2.
9. 9 is the perfect square that divides 18.
Oh yeah, it is, because 3 and 3.
Okay? So this is the square root of 9 times the square root of 2, which is 3 radical 2. All right, now I'm going to pause and wait for you to do the other two. So what factor of 50 is a perfect square? 25.
7.
So I've got the square root of 25 times the square root of 2, which is 5 radical 2. We good?
Yes.
What square root of 54 is a perfect square? 9. Nice.
Yo.
Okay? 6 is only divisible by 2 and 3. Neither of those are perfect squares. So I have the square root of 9 times the square root of 6, which is 3 radical 6.